NASA's James Webb Space Telescope has hardly opened its eyes, and the universe is new, more mysterious, more beautiful than humanity's dreams.
Scientists looking for life on other planets like to talk about the Goldilocks zone, not too hot, not too cold, but just right. And now NASA's found a planet that's right in that zone.
The holy grail of astronomy is to find the closest Earth-like twin, a doppelganger in outer space. And now we've nailed it. After looking at 4,000 extrasolar planets, we finally found the closest one that looks very similar to the planet Earth, we think. Think about that.
Astronomers have found clear evidence of what could be an Earth 2.0. This artist rendering shows the rocky planet identified as Proxima B orbiting the Proxima Centauri star.
Proxima Centauri is the closest star to our planet apart from the sun, and it is about 4.25 light years away.
So if it had an atmosphere like Earth, there'd be 70 degrees there right now.
70 degrees, and that's what makes scientists believe that the potential is there for life.
The potential is there, and it's very exciting because in the catalogs of planets that we now have, this is the first time.
Astronomers have recently made a surprising revelation regarding the dark side of Proxima Centauri B, a hemisphere that has not experienced sunlight for years. Initially, we thought this side was merely a frigid, barren shadow, but new observations are uncovering something unexpected. A faint yet unmistakable signal is emanating from the darkness. As scientists investigate the obscured side of Proxima Centauri B, it is becoming evident that emissions are present, subtle but distinct signals that could be unlike anything we've encountered before. These emissions may manifest in various forms, such as artificial light, heat, radiation, or other types of electromagnetic waves, like infrared. Unlike natural starlight, these signals possess a unique signature, indicating they may be man-made or the result of an advanced system. Unlike the steady glow of a distant star, these emissions can be detected using powerful telescopes like the James Webb Space Telescope, JWST. JWST is specifically designed to identify infrared radiation, which is precisely the type of faint energy that might be escaping from Proxima Centauri B's dark side. What if these emissions are not merely lights, but hint at something even more fascinating about Proxima Centauri B? Could these signals narrate a story yet to be uncovered, one that points to a hidden civilization, or a mystery far deeper than we could have imagined? The implications for potential inhabitants are significant. How could the emissions from Proxima Centauri B's dark side help us learn about any life forms that may exist there? The faint emissions could signify more than just energy usage. They might be crucial for understanding the planet's inhabitants. If these emissions are indeed artificial, they could suggest a technologically advanced civilization. The specific patterns of light and heat could reveal the type of technology in use, the scale of energy production, and even provide insights into the social structures of the planet. Just as the lights of Earth cities tell the story of our political boundaries and social conditions, the emissions from Proxima Centauri B could reflect an entire civilization's values and priorities through their energy consumption. Could the dark side of Proxima Centauri B reveal more than just city lights? What if it showcases an alien society in action, how they govern, their technological advancements, or even their challenges? These faint signals may offer us our first glimpse into an entirely different way of life, light years away. Tidal locking and its effects on emissions are also noteworthy. Tidal locking significantly influences the emissions on Proxima Centauri B, as one side perpetually faces its star while the other remains in total darkness. This means that the dark side, unlike Earth's night cycle, never receives sunlight, remaining in constant shadow and becoming extremely cold and inhospitable. Without a source of heat or light, artificial illumination would likely be essential for any life that exists there. These lights would not only provide warmth, but also make the dark side habitable. Without these artificial energy sources, the dark side would be too frigid and dark to support life as we know it. The unchanging nature of tidal locking creates a consistent pattern on the dark side, suggesting that the emissions detected could be steady and predictable. In fact, astronomers might be able to measure these artificial emissions, revealing how much energy is being utilized to sustain life on that side of the planet. Future telescopes like JWST and the proposed LIR are designed to detect incredibly faint emission signals that could indicate the presence of extraterrestrial life. These advanced instruments are equipped with technologies that allow them to capture narrow bands of light, particularly in the infrared spectrum, which is crucial for identifying artificial emissions. Unlike the natural starlight that floods our observations of distant stars, these faint signals could be distinctly different, enabling astronomers to detect something far more exciting: artificial light. What sets JWST apart is its ability to focus on very specific wavelengths of light emitted by artificial sources. The infrared sensitivity of these telescopes allows them to detect heat radiating from a planet, even from light years away. This is vital because the artificial lights that might illuminate Proxima Centauri B's dark side could emit heat detectable through this infrared lens. By analyzing these wavelengths, astronomers can differentiate between natural starlight and the unique signature of artificial light. The potential to detect these faint emissions could mark a groundbreaking shift in our search for life beyond Earth. We are on the verge of discovering not only new planets, but also potentially signs of intelligent civilizations. The technology behind JWST and LIR could help us identify a civilization on a distant world simply by detecting a pattern of light unlike anything we've ever encountered. But there's more to consider. What kind of technology would be necessary to create these artificial lights on Proxima Centauri B? The implications of this discovery extend far beyond merely detecting emissions. They could reveal the technology that enables life to thrive in an otherwise inhospitable environment, making the dark side of Proxima Centauri B habitable. Extraterrestrial civilizations would need to rely on advanced technologies to generate light and heat. One possibility is the use of photovoltaic panels, solar cells that convert sunlight into electricity. Although the dark side of the planet does not receive direct sunlight, these panels could be positioned on the permanently sunlit side, harnessing solar energy and storing it for use on the dark side. Other advanced energy sources might include nuclear fusion reactors, which could generate vast amounts of power without relying on solar energy, or even technologies like artificial photosynthesis, which mimics the process plants use to convert light into energy. These artificial lights would serve two essential functions: providing illumination and warmth to make the dark side livable. Just as Earth relies on electricity for everything from streetlights to homes, the inhabitants of Proxima Centauri B could depend on sophisticated lighting systems to not only illuminate their world, but also maintain a habitable temperature in the constant shadow. Could these artificial lights indicate something much larger, perhaps an advanced technological society? The lights themselves may not just be survival mechanisms. They could point to a civilization with remarkable energy management and engineering capabilities, as well as the ability to control their environment on a scale we have yet to imagine. While emissions from the dark side of Proxima Centauri B have been detected, the challenges in fully understanding or analyzing them are significant. First, the vast distance between Proxima Centauri B and Earth makes it extremely difficult to isolate the faint signals coming from such a distant world. Even with the emissions we've detected, their faintness could make it hard to distinguish them from background noise. Solar flares from Proxima Centauri and cosmic radiation further complicate the task, potentially interfering with the clarity of the signals we are trying to study. However, advancements in telescope technology are pushing the boundaries of what is possible. Instruments like JWST and future telescopes like LIR are designed to focus on specific wavelengths of light, including the infrared emissions that could originate from Proxima Centauri B. These instruments are incredibly sensitive, and with their help, astronomers can isolate these emissions with greater accuracy despite the distance and interference from cosmic phenomena. Could Proxima Centauri B's natural emissions mislead scientists into thinking the planet is just another barren rock? despite the breakthroughs in detecting emissions, it remains possible that what we've identified is merely the beginning. With the right advancements in technology, the real story may still be hidden beneath a layer of cosmic noise. While emissions from Proxima Centauri B's dark side have been detected, it is possible that some of these signals could be natural phenomena rather than artificial lights. Earth itself provides examples of such emissions, like the shimmering auroras caused by interactions between solar wind and our magnetic field. Volcanic activity or atmospheric phenomena on Proxima Centauri B could produce similar glowing emissions. In fact, the planet's unique position and environment, constantly facing its star on one side, could lead to dramatic volcanic or geothermal activity, releasing heat and energy into the atmosphere. This complexity could make distinguishing between artificial light and natural emissions particularly challenging. Just as auroras on Earth can sometimes appear bright and otherworldly, volcanic lighting or intense storm activity on Proxima Centauri B might emit signals that could be mistaken for a city's glow. The faintness and irregularity of these emissions might cloud our understanding of what is truly happening on the dark side. Could Proxima Centauri B be concealing something beneath its surface? What if these emissions are not from a city, but from a planet teeming with volcanic activity? The mystery beneath the planet's surface might be far more intricate than we ever imagined, suggesting that the dark side of Proxima Centauri B could harbor a dynamic, ever-changing environment. Proxima Centauri B's atmosphere could significantly influence the emissions detected from its dark side. If the planet has an atmosphere, it could act as a filter, altering or absorbing certain wavelengths of light before they reach our telescopes. This means that even if artificial lights are shining brightly on the dark side, some of that light might be absorbed or scattered by the atmosphere, making detection much more difficult. The composition of Proxima Centauri B's atmosphere, whether it is rich in gases like carbon dioxide, nitrogen, or even exotic compounds, could change how the light behaves as it travels through it. For instance, certain gases can absorb specific wavelengths of light, altering the light's spectral signature by the time it reaches our instruments. What this means is that even though we might be detecting something from the dark side, we may not fully understand its true nature without considering how the atmosphere has affected the emissions. What if Proxima Centauri B's atmosphere holds the key to understanding how emissions from its dark side could reveal the planet's history? The way the atmosphere filters these emissions could provide insights into the planet's past, how it developed, what kind of environmental changes it has undergone, and whether it is capable of supporting life. By leveraging the power of next-generation telescopes like JWST and LIR, we are on the brink of unlocking profound discoveries. These instruments could reveal faint emissions from Proxima Centauri B's dark side, potentially unveiling signs of life or technology on a distant world. With these breakthroughs, we'll not only answer questions about the planet's habitability, but also open the door to exploring what could be an entirely new chapter in our search for extraterrestrial life. The future of space exploration is thrilling, and with each advancement, we get closer to discovering whether we are truly alone in the universe. These discoveries will transform everything we know about the cosmos, and we are standing on the edge of something monumental. If you enjoyed this journey into the unknown, don't forget to like and subscribe for more updates as we continue to explore the mysteries of the universe.